For the 2017 free response question number 3, they're giving you the graph of f prime, okay, and and it's a closed interval, and they're also telling you that f of -2 is equal to 7, okay, and they're going to ask you some questions. This is made up, and it's pretty clear from the diagram. It's made up of some line segments and then a semicircle right here, right? Okay. All right, so let's go ahead and for part A, let's find the value of f of -6 and f of 5, okay? All right, we'll go to our paper and we'll do that one. All right, so what's important here is that we know that f of -2 is equal to 7, okay? Because we need that fact because we're gonna integrate to get f of -6, okay? So we know that if we integrate, okay, from let's go -6 to -2 of f prime of x dx from the fundamental theorem of calculus, we know that that has to be equivalent to f of -2 minus f of -6. Okay, so we know this one, right? We can replace this one with 7, all right? And this one, I'm going to move to the other side. Well, actually, I'm going to move this one to the other side and the integral to this side, okay? So if I'm going to add both sides, that would give me f of -6 is equal to f of -2, and then minus, and I'm going to move this integral to the other side. Okay, so that's the integral from -6 to -2. And I chose -6 to -2 because then that would give me, I'd be going from left to right when I integrate. Okay, f prime of x dx. Okay, so that means f of -6 would have to equal f of -2, which we already know is 7, minus, okay, and then we're going to do area from -6. We're going to use area to figure out this integral, okay? So I'm going to go back to the graph, and we're going to go from -6 from right here to right here, okay? So this is going to be 1/2 this height, which is 2, and then this base, right, which is this is -2 right here, okay, because we're going by ones. So this would be 1, 2, 3, 4, right? So 1/2 2 times 4. So minus 1/2 2 times 4. Okay, so that means f of -6 would have to equal 7, and then minus, and then this would just be minus 4. Okay, so f of -6 we now know is 3. Okay, and that's how you find f of -6. We're going to do something very similar with f of 5. Actually, f of 5 is a little bit easier, I think. Okay, so for f of 5, we're going to go, this time I'm going to go from the integral from -2 to 5. Now, why am I always using -2? Because I know that value, right? So f prime of x dx, okay, and I know that's going to have to equal f of 5 minus f of -2. Now this time I'm going to move this one over, okay? So f of -2, okay, plus the integral from -2 to 5 f prime of x would equal f of 5. Okay, this just bothers me. This is just me, okay? I want f of 5 to be on the left side, so I'm just going to rewrite it, all right? So f of 5 is equal to f of -2. I probably wouldn't do this if I was taking the AP exam, okay? Just because of time. Plus the integral from -2 to 5 f prime of x. And you guys, I forgot my dx right here. So there should be a dx. Okay, and then dx. Okay, so now I know f of 5 is equal to f of -2, which we know is 7, plus, and then the integral, right? Whoops, I don't need the integral. I'm going to actually figure it out. Let me take the integral symbol off. Okay, sorry about this, guys. Okay, so we want to do the integral from -2 to 5, right? So from -2 all the way to right here is 5, right? 1, 2, 3, 4, 5. That's 5 right there. Okay, so we want to go from here all the way to here. Now, all of this, because it's below, my function values are negative, and I'm integrating left to right, so all of this is going to be negative area, okay? So this would be plus all right? And it's going to be negative 1/2, because it's a half a circle, pi times my radius, okay? And the radius of this is 2, so minus 1/2 pi 2 squared, okay? And that takes care of the integral part from -2 to 2. Now I want to take care of the integral from 2 to 5, right? And this is just a triangle, okay? This would be the height right here, and this would be the base. So to this, we're going to want to add 1/2, and this would be 1/2 2 times 3, right? So 1/2 2 times 3. Okay, and so that means f of 5 is equal to 7, and this is 4, and we're going to take half of that, right? So that'd be negative 2 pi, so minus 2 pi, and plus 3, right? So that means f of 5 would be 10 minus 2 pi. Okay, and that's the answer for f of 5. Okay, this would be, if you left your answer right here like this, that's an unsimplified answer, but it's correct. So if you stopped right here, it'd be right. Actually, even right here, if you stopped right here, you'd be correct. Okay, because you have a numeric answer. Okay, it just hasn't been simplified. Okay, so you could stop right there. Okay, all right, so that's the answer to part A. Let's go on to part B. Okay, so for part B on number 3 is on what intervals is f increasing, and then we want to justify our answer, okay? So we're going to use where f is positive, right? Or f prime is positive, okay? Because where f prime is positive, we know it's going to be increasing, okay? All right, so let's go to my paper, and I'm going to answer this, all right? All right, so grabbing the graph, okay, I know that f prime is positive from -6 to -2, including -6 and not including -2, right? Because it's 0 there. And then it's also positive between 2 and 5, right? Okay, so that's where f prime is positive, okay? Okay, so f prime of x is greater than 0 on, okay, and it would be -6, including -6 to -2, okay, and, or you could put a union here, okay, and it's also positive between 2 and 5, okay. Now, because it's positive on these intervals, okay, f is increasing on, okay, so bracket, it's going to be increasing at -6. And okay, some people, it's going to stop increasing at -2. Now at -2, the derivative is 0. I know, but we can include it there. Okay, so some people include this and some people don't. So right here, you could also, an option would be to have a parenthesis. Okay, some people include the -2, some people don't. It's not always agreed upon whether you include it or not. Okay, so they're going to accept it either way. Okay, and then or you can have a bracket or you can have a parenthesis right here on the -2. You have to have a bracket on the -6. Okay, and then it's also increasing on this and this interval. Now, I would do bracket 2 to 5 bracket. Now at 2 and 5, the derivative is 0, right? But that's where it starts to increase again, and that's where it stops to increase, okay? So again, these could be, you could also have an open parenthesis, or right here, you could have a parenthesis, okay? So there's two ways to write this. You can go bracket -6 to -2, bracket or parenthesis, and the 2 to 5, you can do brackets or you can do both parentheses, okay? All right? Maybe I should just write it like this. So you could write it like this too. So they would accept this as a way of answering it, and they would accept this way as a way of answering it, okay? And that's it. We justified our answer because we're looking for where f prime is positive, okay? So now let's go on to part C. You guys, I know on a lot of these videos, I'm doing a lot of talking and explaining, but it's really to help you prepare you and get you ready. I know it's not just the answer, it's like explaining. So these take longer than just doing the problem. I mean, okay. So I want you to understand like why we're doing it, okay? So especially like this one, okay? So part C, find the absolute minimum value of f on the closed interval, -6 to 5, and then justify your answers. Okay, so we have a closed interval, right? So it's the closed interval test, all right? We want the absolute minimum. Now, we can find the critical values, but you could also just check the endpoints, right? We're going to want to check -6 and 5, all right? And then we want to check, we don't need to check all of them because we're not looking for the absolute min and the absolute max. We're just looking for the absolute minimum. So this could save some time. So we're looking for where f prime changes from being negative to positive, okay? So from negative to positive. So all we would need to check is the endpoints and where f prime changes from negative to positive. So it's changing from negative to positive at 2 right here, right? Okay, at 2. So we just need to find f of -6, f of 2, and f of 5, okay? Now, why am I not checking f of -2? Okay, f of -2 is a relative maximum, right? So it can't be an absolute minimum because it's a relative maximum right there, right? Because the derivative is changing from positive to negative, okay? All right, so all we need to do is check 2. All right, so let's do that in part C. Okay, so for part C, we want to find f of -6, right? And you know what? We already figured that one out, right? I'm going to go back to my paper, okay? F of -6 is equal to 3. So you don't need to show this work again, okay? You can refer back to part A, okay? So we know f of -6 is 3. Done with that one, right? We also need to find f of 2, okay? Why f of 2, okay? Because that's where the integral, or that's where the derivative changes from being negative to positive, okay? So that means we're going to find the integral. Well, hold on. Let me, I can't write this yet. We're going to want to define this. We're going to do the integral from -2 to 2 of f prime of x, right? dx. And then that's going to equal f of 2 minus f of -2, right? So f of 2 is going to have to equal f of -2 plus, right? I'm just moving this over and I'm writing f of 2 on the left-hand side, plus the integral from -2 to 2 f prime of x dx, okay? So now what do I know? F of -2 is 7, right? Because that was told to us, all right? And then we know that this is a semicircle. Okay, so I'm grabbing my graph. So from -2 to 2, it's a semicircle with a radius of 2, okay? So that's going to be minus 1/2 pi times my radius of 2 squared, right? So that would be 7 minus 2 pi, okay? So 7 minus 2 pi. Okay, now which of these is the smallest right now, right? Okay, so this one would have to be the smallest. Pi you can estimate with being like about 3, right? So this would be 7 minus 6. So this would be 1, okay? And it's actually less than 1 because pi isn't 3. It's a little bit bigger than 3, okay? So you know this one's smaller right now, okay? So now we also need to do f of 6, right? Not f of 6, f of 5. And we had f of 5, right? F of 5, we calculated in part A, right? F of 5 from part A was 10 minus 2 pi. So this is equal to 10 minus 2 pi, okay? So if pi is about, if we're using to eyeball this, okay? If pi is about 3, this would be 10 minus 2 times 3, which is 6, okay? Right? And so this is actually less than, it's not 6, it's less than 6, but not by much, okay? So that means this one has to be smaller, right? Okay? All right. So this one is the smallest one, and that has to be the absolute minimum. So F has an absolute minimum of, and it would be 7 minus 2 pi at x equals 2. Okay? And because that's what it was asking you, right? Find the absolute minimum value of f on the closed interval. Justify your answer. So our justification is we're checking the critical points, right? Okay, and then the endpoints. Okay, all right. And if you look at the scoring, if you were to look at the scoring on this, they're giving you a point. I'm pulling my scoring up. They would give you a point for checking this f of 2, okay, and then doing your endpoints, okay, and then writing your answer, okay. That's the second point. So this is a 2-point problem, okay. All right, let's go to D, okay. So for part D, it says for each of f double prime at -5 and f double prime of 3, find the value or explain why it does not exist, okay. So we're given the graph of f prime. So f double prime is the derivative or the slopes from the graph of f prime, right? So right here at -5, that would be right here, right? The slope right there. Well, on either side of that, the slope would be the same because that's a straight line, right? Okay. And so coming into this, the slopes on either side of this are going to be the same value. And so that would just be the slope of this entire line right here. So it's going to exist. So let's go to our paper and let's go ahead and figure that one out, okay? So for part D, I know f double prime at -5 is going to equal, and it's going to wind up being the slope, okay, for these 2 points right here, this point and this point, right? So it's going to be 0 minus 2 over, okay, since I started with this one, I'm going to start with -2, -2 minus -6. Now, if you, on the top, if you wrote 2 minus 0 over -6 minus -2, you'd be right. Okay, so that's -2, and this would be -2 plus 6, which would be 4, and then that would give you -1/2. Okay, so f double prime of -5 is -1/2. Okay, now at 3, that's a different situation. Okay, because at 3, the left side, right, is going to be, that's going to be this slope, and the right side, this is the left side derivative. Okay, and then the right side derivative is going to be this slope right here, right, because these are made up of 2 lines. So what that would mean is f double prime of 3 does not exist. Okay, now we gotta give a reason why. Okay, so I'm going to go back to my paper here, and let's say f double prime of 3 does not exist. Okay, now we're going to use the definition of derivative at a point to figure this out. Okay, so we're going to take the limit as h approaches 0 from the left of f of f prime, sorry, f prime of 3 plus h minus f prime of 3 all over h. Okay, now what is this? This is the left-hand derivative for f prime. Okay, now there's an alternative way of writing this, and I'll show you that in a minute. Okay, but this slope right here, all right, we're going to go up. We're going to go up 2 and over 1, right? So this slope is equal to 2. Okay, and then we could also say the limit as h approaches 0 from the right of f prime of 3 plus h minus f prime of 3 over h. And that would be the slope for this one, right? So this one it's going to be negative, right? And we're going to go down 2 and right 2. So that'd be a slope of -1. So these one-sided limits don't exist, right? Or these one-sided limits differ, right? And that's why f triple prime of 3 does not exist, okay? Because the limit as h approaches 0 doesn't exist, okay? So the limit as h approaches 0 of f prime of 3 plus h minus f prime of 3 over h does not exist. Because remember, for limits, for this to exist, the one side limits have to be the same amount, right? They have to equal each other, and they don't, okay? So there's an alternative form for definition of derivative. It's on your card stock, okay? So another way of doing this is you could take the limit as x approaches 3 from the left of f prime of x. Hold on a second. Yes, f prime of x minus f prime of 3 over x minus 3. It's an equivalent of this, okay? And so this one is, this is the derivative at 3, but it's the left derivative, okay? And this would equal 2, okay? Because we're approaching 3 from the left side, right? And so some of you, this might make more sense, okay? And then if we do this one, it would be the limit as x approaches 3 from the right of f prime of x minus f prime of 3 over x minus 3. And this is the right-hand derivative, okay? And then this one would equal -1, okay? So it's just two different ways of writing the same thing, right? And then we would say the limit as x approaches 3 of f prime of x minus f prime of 3 over x minus 3 does not exist, right? And this is the definition of f prime of 3, right? So f prime of 3 does not exist. Not f prime, f triple prime. F triple prime of 3 does not exist. So this is the formal write-up of why it doesn't exist, okay? And that's D, and we are done for today, okay? All right, so you guys take care. I will see you in the next lesson. So for the 2017 free response question number 6, what they're giving you is a function, right? And they're giving you some different values, that f of 0, f prime of 0, and then they're giving you the n+1 derivative at 0, right? And they're giving you a formula for that right here. And then they're also telling you that it's a Maclaurin series, which means it's centered at x equals 0, so we can use these to write out a Maclaurin series, and that f converges to f of x for the absolute value of x is less than 1. So that means x is between -1 and 1, okay? So for part A, show that the first four non-zero terms of the Maclaurin series, which is a Taylor series centered at x equals 0, for f is this, right? And then write the general term of the Maclaurin series for f, okay? So let's go ahead and do that. Let's go through and do some derivatives. Let's figure out some of these derivatives, and then we're just gonna plug them in, okay? All right, so I'm gonna go to my paper and we'll do part A. Okay, so I know that f of 0 is equal to 0, okay? So because this is turning out to be 0, I'm gonna have to go all the way to the fifth derivative to get 4 terms that are non-zero, I think. Okay, Okay, so we know f prime of 0 is equal to 1. And so now we need to find the second derivative, right? So f double prime at 0. Okay, so now we got to use this formula right here, okay? Because n is 1 here, okay? So because that would make the second derivative, that would make this a double prime. All right, so that would mean n is 1. So this is equal to -1 times f to the first derivative, right? So f prime at 0, okay? So to figure out the next derivative, what we're going to have to use is we're going to have to use the previous derivative, okay? So this is equal to -1, and then this is 1, which is -1, okay? And then we're going to have to do f triple prime at 0, okay? And this is negative n, so this is going to be -2 f double prime at 0. So that'd be -2 times, and we got over here -1. So that becomes 2. Okay. So now we have 1, 2, 3. We have 3 terms. Okay. 3 non-zero terms. I said the fifth derivative. I was mistaken. It's the fourth derivative, okay, that we're going to need to find. Okay, so the fourth derivative, okay, at 0 would be negative 3 times f triple prime at 0. And that this one was 2, so this is negative 3 times 2, which gives you negative 6. Okay, so the first four non-zero terms, remember for a Taylor series or Maclaurin series, it's going to be at 0. It's going to be f of 0 plus f prime of 0 times x to the first over 1 factorial, right? And then plus f double prime. I'm not writing 1 factorial because it's just 1. So f double prime at 0 of x squared over 2 factorial, and then plus f triple prime at 0 times x cubed. This is really x minus 0, but we're not writing x minus 0 because that's just x over 3 factorial. And then we need one more, right? So plus the fourth derivative at 0 over 4 factorial times x to the fourth, and then plus dot, dot, dot. Okay, now we're going to get a general term in here, okay? So now we know that this is 0, so we really don't need to write that one. So f prime of 0 is 1x, so this is going to be x, and then plus, and then, you know, we should write this. Taylor polynomial is this, okay? And then, so then this would be f double prime is negative 1. So this would be negative 1 over 2 factorial, which is 2 x squared, and then plus, and f triple prime of 0 is 2 over 3 factorial, which is 3 times 2 times 1, which is 6 x cubed, and then plus, and then the fourth one is negative 6. The fourth derivative at 0 is negative 6 over 4 factorial, which is 4 times 3 times 2, right? And that would be 24 x to the fourth, and then plus dot, 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 okay? And so p sub n of x, the nth order Taylor polynomial, would be x minus 1/2 x squared, or that's x squared over 2, plus, and then this reduces to 1/3 x cubed, and then this becomes negative 1/4, so minus 1/4. You know what? I'm writing it wrong. Sorry. And it wouldn't be wrong. I just want to match up with what they wrote. That's the only reason I'm rewriting it. Okay. So this is x cubed over 3. The math was right. Okay. X cubed, and then minus, and then this would be 1/4. So x to the fourth over 4 plus dot, 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 right? And this would be plus. Okay. Now notice it's alternating, right? Okay. So we need to do a negative 1 to the n, right? Okay, now if we do 2 here, if we started at 2, okay, there's going to be a problem because this is going to become positive, right? So this needs to be n plus 1. And then x to the n over, and if you look at this, the powers match, right? So this power has to be the same as the number in the denominator, so that would be n, and then plus dot, 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 okay? And so if we write the sigma notation, actually, let's go ahead and do that. If we do the sigma notation and we start at n equals 1, okay, then that would give us this one, right? Okay. And because this would be 1 plus 1, which is 2, and negative 1 squared would be positive because that first term is positive, right? And we go to infinity of negative 1 to the n plus 1 x to the n over n, okay? So we have the first four non-zero terms, 1, 2, 3, 4, and we have the general term, right? And we wrote the series, okay? All right? Okay. All right, so let's go. and we answered part A. Let's go ahead and go back and look at part B. For part B, we want to determine whether the Maclaurin series described in part A converges absolutely, converges conditionally, or diverges at x equals 1. And then we're going to we'll have to explain our reasoning. Okay? All right, so let's go ahead and do that. So for part B, we have the series, right? Sigma n equals 1 to infinity of -1 to the n, okay? And then at x equals 1 is what we're trying to find, right? Then this would be x, which would be 1 to the n, right? Over, okay, n. Now 1 to the n is just going to be 1, right? So this becomes sigma n equals 1 to infinity of just -1 to the n over n. Okay, so now what we're going to do is we're going to check for absolute convergence. So this series at x equals 1 becomes this one, which ultimately becomes this, right? At x equals 1. Okay, these are endpoints, right? Okay, so then what we need to do next is we're going to check for absolute convergence. So n equals 1 to infinity, the absolute value of -1 to the n over n. This series, when you take the absolute value of it, becomes this series, right? Because -1 to the n, this is going to be negative or positive, but when we're taking the absolute value of it, it's going to be positive, right? So this becomes n equals 1 to infinity of just 1 over n without the absolute value, because that n is going to be a positive value, so we don't need the absolute values for this denominator. And what do we know about this? That's the harmonic series, right? And so since this is the harmonic series, we know this diverges, okay, because sigma n equals 1 to infinity of 1 over n is the harmonic series which diverges. You could also use the p-series test. Okay, so that means the series, right? Because it was asking you, determine whether the Maclaurin series described in part A converges absolutely, converges conditionally, or diverges at x equals 1. So it is not, because this is the absolute value of it, right? It is not converging absolutely, okay? The series described in part A is not absolutely convergent, okay? Or does not, or I should say does not converge absolutely. Okay, now how about conditionally, right? Okay, so now we got to look at the actual series itself, right? N equals 1 to infinity of -1 to the n over n. Well, what do you notice about that? That's the alternating harmonic series, right? And what do we know about the alternating harmonic series? It always converges, right? So this converges because sigma n equals 1 to infinity. And I just realized you guys can't see this, so let me scooch it up. Okay, so converges because sigma -1 to the n over n is the alternating harmonic series which converges. Okay, all right, so what does that mean? It's conditionally convergent, okay, at x equals 1. So we would say sigma n equals 1 to infinity of negative 1 to the n plus 1 of x to the n over n is conditionally convergent at x equals 1. Okay? And that's part B. Okay? All right, they are definitely, I know. They are going to ask you some type of Maclaurin-Taylor infinite series question on the BC exam. And here's why. That's really the only part of BC. That's the only whole unit from BC that's going to be covered. Okay? So I know they're going to ask probably multiple questions on something like this. Okay? All right, so let's go to part C. Okay, so for part C, we want to write the first 4 non-zero terms of the general term of the Maclaurin series for g of x is equal to the integral from 0 to x of f of t dt. Now remember, the Maclaurin series that we were doing at the very beginning in part A was a Maclaurin series for f, right? Okay, so we're going to integrate this. Basically, we're going to integrate our Maclaurin series. Okay. All right, so let's go ahead and do that, and we'll go to our paper. Okay, so for part C, we know that g of x is equal to the integral from 0 to x of f of t and then dt, okay? So that would mean g of x is equal to the integral from 0 to x of t minus t squared over 2 plus t cubed over 3 minus t to the 4th over 4, right? And then plus ... and then plus negative 1 to the n plus 1 x to the n all over n. Okay? All right, and then dt. You know what I forgot to do? This x should not be x right there. That should be a t. So let me change that. Right? Because over here, because the function is in terms of t, and we're integrating to x, which will make it, when we do the integration, we're going to put x's in, okay? So this would be t to the n. Sorry about that. Okay? And now it's a matter of just integrating this, okay? So this is going to be, so g of x would equal, okay, so this is going to add 1 power and divide by it, right? So this first term is going to be t squared over 2 minus t cubed, okay? And we would divide by that new power 3, right? But dividing by 3 is the same as multiplying by 1/3. So this actually becomes 2 times 3, okay? And then plus t to the 4th over 3, and we divide by 4, right? That's the same as multiplying by 1/4. So that's the denominator would be multiplied by 4, okay? And then minus t to the 5th over 4 times 5, right? Wouldn't it? And then plus ... and then plus and negative 1 to the n plus 1. And this would be t to the n plus 1 over n. And you notice from over here, this would be n plus 1. Okay, and then plus ... Okay, so g of x, whoa, and I forgot. Okay, we got to evaluate this from 0 to x. Okay, now what's going to happen everywhere we see t, right? We're going to replace it with the x. So what happens when we do this one? Well, all of these are going to be zeros, right? Okay, so g of x is going to equal, and this would be x squared over 2 minus x cubed over 6 plus x to the 4th over 12 minus x to the 5th over 20 plus ... okay, plus negative 1 to the n plus 1, x to the n plus 1 over n times n plus 1 plus dot dot dot, and then minus, and I'm just gonna, you wouldn't have to put this in here, okay, but because all of these are gonna be 0, right? So minus 0. I'm just putting that because I want you to realize, okay, we put x in and then we put 0 in, but when we put 0 in, that's gonna be 0, right? So really this doesn't need to be here. So our function g of x becomes x squared over 2 minus x cubed over 6 plus x to the 4th over 12 minus x to the 5th over 20 plus dot dot dot, and then plus, and then it'd be negative 1 to the n plus 1 x to the n plus 1 over n times n plus 1, okay, plus dot dot dot, because it keeps going forever, right? And so this would equal, in sigma notation, it would equal sigma n equals 1 to infinity of negative 1 to the n plus 1 x to the n plus 1 over n times n plus 1. You just have to tag on the sigma notation, right, to this, and you'd have the series, okay? All right, I think that's it for C. I think that's all we need to do, okay? Write the first 4 non-zero terms in the general term of the Maclaurin series. And I'm gonna say this, you wouldn't have to do this, okay? That's a little bit extra, okay? Because when you do the first 4 terms, first 4 non-zero terms, that's these, right? So we did that. This is the general term. So if you wrote it like this, okay, and you need the plus dot dot dot, okay, if you just left it like that, you're perfect, okay? Because you've done what they asked you, the first 4 non-zero terms and the general term, okay? You could even write this plus this plus this plus this plus dot dot dot, and then down here write general term is, and you just name it, okay? The general term is this, okay? You could do it that way too, okay? All right, so let's go to part D, all right? For part D, they're telling you let P sub n, right? That's the nth order Taylor polynomial, okay, or nth degree Taylor polynomial. Degree and order are the same thing, okay, in these. For G about x equals 0, that's what we found in part C, okay? And evaluate it at x equals 1/2, where G is the function defined in part C. I just said that, okay? Use the alternating series error bound to show that this error, right, has to be less than 1 over 500, okay? All right, so remember alternating series error bound, if we're doing the 4th one, right, we got to compare this to the 5th term, right? So n is 4 to, we got to do n is 5, right? Okay, so I'm going to go to my paper and we'll answer this one. Okay, guys, for part D, all right, we have the 4th degree Taylor polynomial at 1/2 minus G at 1/2, right? Okay, and this was an alternating series, right? Because of the negative 1 to the n plus 1, okay? Now, this 4th one, okay, we're using the first 3 terms to do this. Now, the way you can tell is that this is 4th and this is the 4th power, right? So this is the one that we're using. And remember in the alternating series error bound, okay, it was the next term, right? And what we have right here is the next term. So this error has to be less than or equal to the absolute value of negative of 1/2 to the 5th over 20, right? Okay, so that means that the absolute value of the 4th degree, 4th order Taylor polynomial at 1/2 minus the actual function value at 1/2 has to be less than or equal to, okay, now the absolute value of this, right? So the absolute value of this negative is going to go away, right? So this is going to be 1 over 2 to the 5th, and 2 to the 5th is 32. So this is 1 over 32 over 20, right? And then we could multiply both top and bottom by 20 over, 20 over 20. And then we would have, okay, the 4th degree Taylor polynomial at 1/2 minus G of 1/2 is less than or equal to, and this would be 1 over 32 times 20. Okay, now I'm going to break this up so it's a little bit easier, okay? And so let's write this again. I'm going to break it up so it's a little bit easier to calculate, okay, mentally. Okay, so this is 32, and this is times, and 20 could be written as 2 times 10, right? So that means, just like you guys, I get tired of writing this, okay? This error has to be less than or equal to, okay, what's 32 times 2? That's pretty easy. That's 64. And 64 times 10 is 640. So this is less than 1 over 640. So the difference between the Taylor polynomial for the fourth degree Taylor polynomial, which would be using only these first three terms, right? And the actual value, it would be less than 1 over 640, right? But what do we know about 1 over 640? We were trying to establish that this error is less than 1 over 500, right? And 1 over 640 is less than 1 over 500, okay? So therefore, this error, this Taylor polynomial error, let me slide it up a little bit. Okay, the fourth degree Taylor polynomial approximation at 1/2 minus g of 1/2 has to be less than 1 over 500, right? 1/500th, okay? And we've shown that, okay? All right, guys, that's part D, okay? I am sure, I'm confident that they are going to ask you some type of question similar to this, because it's not one you can just go and Google up and look it up, okay? All right, okay. So that's it for the free responses today. And I'll see you for the next solutions, okay? All right, you guys take care. Bye.